Hello there, this is exercise 6C.1. This is our first look at chi-squared and the goodness of fit test. Now we've seen chi-squared already with contingency tables, but there's a second use of it to try to show whether or not a certain set of data follows a certain rule, and it might be, it follows the binomial distribution, for instance, or it follows the Poisson distribution. And whether or not it does can be kind of calculated using this idea of the goodness of fit test. So let's have a look at this then. So the chi-squared goodness of fit test then tests whether a specific belief about the distribution is correct. So here's an example. Suppose a market analyst wished to see whether consumers have any preference amongst 5 flavors of a new fruit drink. So I suppose the guy who's doing this might think to him or herself, look, they are going to be bought in equal numbers, these 5 flavors. And then they do a quick sample. Actually, it turns out that wasn't the case. It seems in our sample that cherry, lots of people like cherry, but not so many people like grape. So of those 100 people that we surveyed, we've got some evidence here to suggest my initial assumption is wrong. Is it enough evidence? And that's where the chi-squared goodness of fit test comes in. By the way, sometimes we call these GOF tests. And you can see the GOF bit comes from goodness of fit. So you often just see these described as GOF tests. Anyway, so let's have a look at this. Note the following. If the original assumption was right, they would all be in equal frequency. And since there are 100 initially, in this particular example, all we do is say 100 divided by 5, there should have been 20. So that effectively gives us our expected data. This is about as easy as it gets when you can just divide a number by 5 and then you know all these 5 numbers. For different scenarios, these are much harder to find, these expected data. And this obviously is the observed data. And the observed data is what we got when we did our survey. And this will go into our calculator in list 1, and this will go into the calculator in list 2. When we come to our calculator, of course. And the calculator we tend to use to do this, on this video at least, is the Texas TI 84 Plus. Now there is an equivalent Casio version, which I haven't got in front of me now, so I won't be using it. But you will find GOF tests on there, and so by all means look that up if you've got one of those instead. So the chi-squared goodness of fit test then looks at the differences between these two numbers effectively. It expected to get 20, got 32, and it works out whether the differences between these values are big enough to say, you know what, this is wrong. They aren't equally likely. Or if they're kind of close enough to go, you know what, we haven't got any evidence to say one way or the other. So this is what we do. Anyway, so our initial assumption, hypothesis, our null hypothesis is that the flavors are chosen in equal numbers. And of course, our alternative hypothesis is that the flavors are not chosen in equal numbers. Now, we always need to do a bit like we did on chi-squared tests on contingency tables. We always need to be able to look at this and go, well, how many degrees of freedom I have? And I need that so I can look in the table. Degrees of freedom, in this case, it's always n minus 1, where n is the number of intervals that we had, or categories we have, or however it's. Now, if you look back, we had 1, 2, 3, 4, 5 flavors. So that's the 5 categories, if you like. N minus 1, therefore, is 4. So we're going to need that in a bit. And we're going to find chi-squared using this formula. Chi-squared is O minus E, all squared over E. Now, we do have to use this formula occasionally, at least in part. So I'm going to do the first question using the formula, and then I'll show you how to use the calculator instead. And we're going to test this claim, it says, at the 5% significance level. Okay, so just remember this formula. We're going to need it now. Now, it was the sum of O minus E all squared divided by E. Worth going back just to check. Yes, it was. And of course, that's what we call chi-squared, for a funny symbol, but there you are. Now, my list 1 and my list 2, if you like, which I'm going to eventually put in my calculator, was my observed and my expected data. And for the data that I had, if I just go back to it, you can see I've got 32, 28, 16, 14, 10. Oops. So I had 32, 28, 16, 14, 10. And of course, I expected to get 20, 20, 20, 20, 20. What can I do with these? Well, I take one away from the other. and that obviously gives me 12, 8. Well, this is -4, the observed minus the expected, but in the end it won't really matter that it's a negative, because as soon as I do that, I'm meant to square it. And so if I square all of these, I get 144, I get 64, I get 16, I get 36, and I get 100. And I'm meant to divide all of these by the actual expected number. So I'm meant to now do 144, and I'm going to divide it by the 20. I'm going to divide this by the 20. All of them are divided by 20, because in this particular case, there was all of them were expected to be the same. Of course, some of these are easier to do than others. Uh, 3.2, I think. And what's that? That is 7.2. And if I add these up, you get 18.0. Well, 18. And so effectively, this tells me my chi-squared value is 18. Now, you should recall what it told us to do in the question. It says test at the 5% level. And if I do that, and I test at the 5% level, now, interestingly, you have to look at the 0.95 part of this, because 95% is underneath, if you like. And if I had 4 degrees of freedom, you may recall, and notice this comes up as a V, which is, well, I'm sure it's not a V, but it looks like a V. And that tells me my critical value there. So my critical value is 9.488. Now what I do here, I say chi-squared is bigger than 9.488, and therefore I'm allowed to reject H0. I have to be bigger than that value. You have to get your head around which way round these will go. Chi-squared needs to be bigger. And because it's bigger, therefore, I can reject H0, and there is sufficient evidence, effectively, that these flavors are not chosen in the quantities expected. So let's just have a look, see what I wrote as my wordy answer. There is enough evidence to reject the claim that the consumers showed no preference for the flavors. Well, there you go. So, warning, the last time we did this, we had expected values for all of them were equal to 20. So this didn't apply. But there is a rule that says expected values must be greater than 5. And if they're not, if expected values are less than 5, you must join some categories together to make sure all categories have an expectation of greater than 5. Now, look, if you use a calculator, these are good notes, so you might want to write these down in your notes. First of all, on this calculator, you have to press the Stat button, which is there, and it comes across the top of the screen. You press Edit. And like I said before, the L1 is the observed data, the L2 is the expected data. So you enter it into L1 and L2. You then, again, you press Stat again, and rather than pressing Edit this time, you go across to the right-hand side from memory, and it says Tests. And if you go up or down, you eventually find this one that says chi-squared GOF Test. And the degrees of freedom, you can change them. You can physically change them to what you think it is, or you can just go down to calculator. You don't really need to know about the degrees of freedom for that. So anyway, here's another question. So this is an exam question, as you can see, an older OCR exam question. A large population of plants consisted of 5 species, A, B, C, D, E. So this is similar to the other one in the proportions. Oh, right, they're not necessarily 20, a fifth each. It's got certain proportions, and it says PA. It tells me at the bottom of the question, which is a bit naughty of it. So it says PA is basically 15% of them. 0.15. PB is 15%. PC and D are 25% each. And PE is 20%. Okay, so that's what we are thinking these plants of this are meant to be in. And a random sample of 120 plants consisted of these numbers. All right, and so based on that, and how many did it? I've got 120 plants. Okay, so my observed data, I can draw up a table if you like. I've got 23, 14, 24, 27, and 32. And my expected data, well, I suppose I've got to do 15% of 120. Now 10% is 12, so that must be 18. And A and B were the same, they're 18. Now these are 25%, that's a quarter of 120, so that sounds like 30 for both of those, and 20% that's a fifth, which is 24, 36. So that, I think, works. Yes, it does. So on that basis, now I've got my observed and my expected data, I'm going to cheat. I'm going to this time not use the formula. I'm going to try and do it on my calculator. So it's all going to be done on my calculator. So my first step is to type them in to list 1, list 2. And then if I'm going to type them into my calculator, again, remember what I do is I've got to, I lost my pen. I've got to press the stat button. So that's what I'm going to do first. Press stat, press edit, number 1, and it tells me to put the numbers in. So I'm going to I'm going to do list 1 first, 23, 14, 24, 27, and 32. I just type them in. I move the cursor over to the right, put list 2 in, 18, 18, 30, 30, 24. You can see that's all I'm really doing. I'm typing the numbers in. And now, having got the numbers in, again, I go back to stat, and across the top it says tests, and so test basically is written here when you do it. And I press up personally. I go up to it says D chi-squared GOF test, and I press that enter. It says observed list 1, yes. Expected list 2, yes. It says degrees of freedom 5. I know it's actually 4. I can type that in if I wish. It gives you the opportunity to change it if there's any complications on the question. Calculate, and it says to me chi-squared. When I do this, hopefully you've got the same thing. Chi-squared equals 6.44. Of course, I need to know what level of test this is. I need to set this test out to be done properly as well. So H0, I would say the proportions are the same as those predicted. Something like that. Basically, you're saying what I got was what I should have got. And whereas H1 says the proportions, and I'm going to write exactly the same thing, are different. Exactly the same, but just with this different bit in the middle as those predicted. So a bit annoying that you have to write all that. It's probably only 1 mark for the 2, but that's doable, certainly. And now it says 10% significance level, so I need 10%. And if I go across and do this, then let's have a look at this. 10%, obviously I now need to look at 0.9. Degrees of freedom, there's still 5, so I think degrees of freedom is 5 take 1 again, which is 4. And degrees of freedom there, I think is 7.779. So I'm going to write critical value equals 7.779. And I suppose, again, my chi-squared, my 6.44 this time, is lower. Oh, that's unfortunate. Because it's lower, I do not reject H0. I've got insufficient evidence, effectively, to say that these proportions are different to those that were anticipated. Now, let's see what my answer said. This is from the exam board. 6.44 is less than this critical value. Do not reject H0. Wordy bit at the end. Notice, without that, you lose a mark. Now, degrees of freedom, then, this is the rule. Now, when we do more of these in exercise 6C.2, and again, actually, I think it's in chapter 7, there's another exercise on GOF tests, which gives you an indication that they're quite important, the fact that we do it 3 times. When you do this, there is, like the question we just saw, there's one constraint. That constraint is commonly called totals, i.e. that once if they was meant to add up to 120, once I've chosen the first 4, the 5th one's kind of already chosen because it has to add up to 120. And that is why we consider this to have 1 less degree of freedom than the number of categories. So anyway, it doesn't really matter. You're going to, when you do these, do n-1 degrees of freedom every time. And we are now going to do some questions, exercise 6C. So thank you very much for watching, and I hope you like that. And I think all YouTubers always say, please subscribe. So please subscribe to the channel, and I hope that you found that useful. Thank you.